Hey everyone, welcome to another episode. Today, we're talking about hydrogenation. So if you could stick around for the entire show, that'd be great. First off, what is hydrogenation? Well, it's when we add H2 unsaturated bonds, usually in alkenes or and this process usually occurs in the presence of some kind of catalyst. Now, this is a super important reaction, and it's commonly used in the food industry, like to make edible fats, but also in petrochemicals, pharmaceuticals, and even fine chemicals. And as a result, there are tons of patents out there on how to do this. And it is an active area of research because people want to find new and better ways of doing it. So, today, let's look at some of the basics of hydrogenation. We'll talk about the mechanism, the different types of reactors used, their pros and cons, and hopefully you'll walk away with a good understanding of the basics of this important industrial process. Let's get started. Alright, so first off, let's quickly walk through the basic mechanism. This is called the Hori-Utapolanya mechanism. First, molecular hydrogen adsorbs onto the catalyst surface and then dissociates into two separate hydrogen atoms. Each hydrogen atom then adds to the multiple bonds of the alkene or alkene substrates, one at a time, forming a series of intermediates. And then finally, the hydrogenated product desorbs from the catalyst surface. And that's it. It's pretty simple, but it has some important implications which we'll talk about later. Now, once you know the mechanism, the next thing you might want to do is think about the reactor. What kind of reactor should I use? And there are a lot of choices. There are four main types of reactors that are commonly used for hydrogenation. The first type is a batch reactor. And these are stirred, pressurized vessels that have heating jackets and agitators. They are very common for hydrogenation, especially in the fats, oils, and pharmaceutical industries. But one of the downsides of these reactors is that they are not very efficient because all of the reactants have to come together in the same vessel. And that can lead to hot spots and runaway reactions. Also, they're kinda dangerous because typically these operate at high pressures, and that means that if something goes wrong, there can be an explosion. And that is why most plants that use these reactors will have lots of them running in parallel to reduce the risk if one of them fails. The second type of reactor that is commonly used for hydrogenation is a continuous flow or a fixed bed reactor. These are tube-shaped reactors that are packed with the catalyst and the reactants flow through them. Now, these are the most efficient type of reactor, and they commonly used in petroleum refineries and other large-scale operations. One downside of these reactors is that they have a pretty big pressure drop across them. And that means that you need a lot of pressure to get the reactants to flow through the tubes. Another downside is that the catalyst tends to deactivate over time, and that means that you have to replace it regularly. The third type of reactor that's sometimes used for hydrogenation is a loop reactor. And these reactors incorporate the reactant and hydrogen into a closed loop that is circulated through the reactor vessel. Now, this helps to improve mixing and mass transfer between the gas and liquid phases, and it also helps to keep the temperature uniform throughout the reactor. And because of that, it's really good for heat-sensitive reactions. And finally, the fourth type of reactor that's sometimes used is called a trickle-bed reactor. And this is a special type of fixed-bed reactor where the liquid reactant trickles down over the catalyst while the hydrogen flows either or counter-currently. This is particularly useful for hydroprocessing reactions like hydrogenation and Okay, so now that we know the different types of reactors that are available, how do we choose one? Well, the best type of reactor for a particular application depends on a number of factors like the type of reaction, the desired throughput, the cost of equipment and operation, and safety concerns. For example, if you're doing a small-scale batch hydrogenation of a pharmaceutical intermediate, then you might use a stirred tank reactor. On the other hand, if you're doing a large-scale industrial hydrogenation of vegetable oil, then you might use a fixed-bed reactor. Alright. So, now that we know the basics of the mechanism and the different types of reactors, let's take a closer look at some of the details of reactor design. Now, one of the most important things to consider when designing a hydrogenation reactor is the mixing and mass transfer between the gas and liquid phases. If the reactors don't mix well, then the reaction, won't go to completion, and you'll end up with a lot of unreacted starting material. In addition, you want to make sure that there is enough contact between the two phases so that all of the hydrogen gas can react. Now, this can be achieved by using impellers or agitators, or by using a loop system like we talked about earlier. Another important consideration is heat management. Hydrogenation reactions are typically exothermic, which means that they release heat, and if that heat isn't managed properly, it can cause the reaction to run away, and that can lead to an explosion. So you need to make sure that the reactor is designed to handle the heat. And that might mean using a jacket to keep the reactor cool, or using a loop system to take some of the heat out. And finally, you need to choose the right catalyst. As we mentioned earlier, nickel is a common catalyst for hydrogenation reactions, especially nickel in the form of rainy nickel. Other common catalysts include palladium and platinum. Now, the choice of catalyst can affect the activity and selectivity of the reaction, as well as the operating conditions like temperature and pressure. For example, some catalysts work better at lower temperatures and pressures, while others are more active at higher temperatures and pressures. Alright, so we just covered some of the basics of hydrogenation and reactor design. Next, let's talk about the operating conditions. As we mentioned earlier, hydrogenation reactions are usually carried out under high pressure, because that increases the solubility of hydrogen in the liquid phase. More hydrogen dissolved in the liquid means more reactive hydrogen available to do the reaction. However, too much pressure can be dangerous because hydrogen is flammable and explosive. So, you need to be careful to operate the reactor within the safe pressure range. One way to do that is to use a back pressure regulator like this one here. And this will keep the pressure at a constant value by automatically adjusting the flow of hydrogen into the reactor. Okay, so now that we know how to control the pressure, let's talk about safety. Like I said earlier, hydrogen is very flammable and explosive, so you have to be careful when working with it. That means using inerting procedures, proper ventilation, explosion-proof equipment, flame arresters, and safe venting protocols. And if you want to learn more about handling hydrogen safely, then definitely check out our previous videos about hydrogen storage and handling. Alright. So we talked about batch reactors, but what about scale-up? How do you go from a small batch reactor to an industrial plant? Well, unfortunately, it's not always straightforward because when you scale up, you increase the amount of reactants and energy, so the reaction rate also increases, and that means that you have to pay attention to things like heat management and safety. One way to address this is to use a series of smaller reactors instead of one large reactor, and that can help to keep the temperature under control, and it also makes it easier to automate the process. Another option is to use a continuous ore flow reactor. And this can be a good option because it eliminates the need for large vessels, and it also allows for a more controlled reaction. And as we mentioned before, this is the preferred method for large-scale industrial operations. All right, so we covered quite a bit of ground today. Let's do a quick summary. Hydrogenation is a common reaction used to add hydrogen to unsaturated bonds, and it is often catalyzed by metals like nickel, palladium, and platinum. The reaction mechanism involves the adsorption of hydrogen, followed by its dissociation, and then the addition of hydrogen to the multiple bond. Now, the choice of reactor depends on a number of factors, and there are several options, including batch, continuous flow, loop, and trickle-bed reactors. Each reactor type has its own advantages and disadvantages in terms of efficiency, safety, and ease of operation. The key to successful hydrogenation is to understand the reaction mechanism and the different reactor types, and then choose the right one for the specific application. Now, I hope you found this video helpful. If you did, please remember to like and subscribe and leave any questions or comments below. Thanks for watching.